Setting up OpenClaw isn't as straightforward as the internet wants you to think. The old approach just got more expensive. The practical edge now comes from changing process, timing, and tooling together. We will map trigger, incentive shift, and downstream impact before the close. And if you've tried to follow those guides, you've already hit the wall. Here's what's happening. OpenClaw, the open-source AI model that's supposed to democratize access to language models, requires some serious hardware muscle. But the narrative online is simple: get Allama, download the model, run it locally. Done. Problem solved. Everyone can do AI now. Except they can't. Not with the hardware most people actually own. The first issue is memory. OpenClaw's smaller variants still demand 8 GB of VRAM minimum if you want any reasonable speed. Most laptops ship with 8 GB of system RAM total. Running the model on CPU instead? You're looking at inference speeds that make waiting for a web request feel like a sprint. A single prompt takes 30 seconds. A paragraph takes 2 minutes. At that point, you're not using AI, you're waiting for it. But memory is just the appetizer. The real issue is what happens after you download the model files. These aren't small. A 7 billion parameter model runs 14 to 16 gigabytes. The larger variants? 30 gigabytes, 40 gigabytes, even 80 gigabytes. Your M2 MacBook with 512 gigabytes storage? You've now committed 5% of your entire disk to a single model. Download 2 or 3 different models, which most people want to do because different models excel at different tasks, and you're fighting storage wars constantly. Then comes the integration problem. Running a model locally is one thing. Actually using it in your workflow is another entirely. The tutorials skip over this. They show you Allama works in isolation. They don't show you how to integrate it with your existing tools. You want to use it inside your IDE? You need to set up API routes, authentication, and compatibility layers. You want to run it with your note-taking app? You need plugins that often don't exist or require heavy configuration. The gap between model running and model integrated is where 90% of people abandon local AI. Here's the real insight. This matters because the narrative of local AI democratization is built on a foundation of glossed-over friction. It's not that local AI is impossible. It's that it requires significantly more technical sophistication than the headlines suggest. For developers and engineers? Absolutely doable. For a creator or analyst who wants to run a powerful model without paying OpenAI monthly fees? You're now signing up for a technical project, not a setup. The second-order effect is critical. This friction is actually slowing adoption of local AI, not accelerating it. The barrier isn't the model license or the hardware cost, it's the configuration tax. Every creator, writer, or analyst who tries the setup, hits the friction, and abandons it as one fewer data point for open-source momentum. This is how the market stays fragmented, not because open models are inferior, but because they're harder to actually use. But here's what's changing. The teams behind Allama, LM Studio, and other local inference frameworks are starting to build proper GUI workflows, one-click installers, and tighter integrations with common software. In the next 6 to 12 months, watch for Docker-based pre-packaged stacks specifically designed for common workflows: AI for writers, AI for developers, AI for researchers. When that happens, the friction collapses. Suddenly, the trade-off equation flips. Local AI becomes genuinely competitive with cloud-based alternatives. Who this impacts most? Indie developers and bootstrap creators who want to own their AI inference stack without monthly fees, but don't have the DevOps chops to troubleshoot compatibility issues. Students in India and other emerging markets where cloud API costs consume a disproportionate chunk of a learning budget. Companies evaluating whether to invest in their own hardware infrastructure or continue paying OpenAI by the token. Regulators watching whether open-source AI infrastructure can actually scale as a meaningful alternative to centralized commercial models. The stakes are real here. If local AI setup remains technically friction-heavy, adoption stays confined to engineers. The democratization narrative flatlines. But if the friction drops in the next year, you're looking at a genuine shift in who controls and runs language models. That's not hype. That's infrastructure economics. And it starts with honest conversations about why the easy tutorials aren't easy. The question to ask yourself right now: are you considering local AI because the technology excited you, or because you believe the simplified narrative online? If it's the latter, pause. Do a real audit of your actual hardware, your integration needs, and your tolerance for troubleshooting. That's the conversation nobody online is having. But it's the one that determines whether you actually ship. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next.